Hi everyone, my name's Karla and I'm a first year PhD student at Newnham College at the University of Cambridge. I'm studying for my PhD at the Scott Polar Research Institute, where I'm looking at the seasonal and annual velocity variations of Antarctic ice shelves. Now, if you don't know what ice shelves are, they're the floating masses of ice in Antarctica that hold back all this grounded ice that is sitting on the continent. A good way to think about ice shelves are like the cork in a wine bottle. So they tend to hold back all this ice on the ground, and if they were to collapse, all this ice would be free to flow into the ocean and cause rising sea levels. We call this buttressing, so ice shelves play a really important role in buttressing, which just means it holds back all this grounded ice and for the moment slows down the rise in sea level that we see. The technique I'm going to use to be looking at this is remote sensing. So what this means is that I use satellite images to map how the ice is behaving in Antarctica. Specifically, I use radar satellites. These are really cool satellites to use because they can be used in the night time. They don't require daylight, which is especially important in Antarctica, where there's no daylight for up to 6 months of the year due to the polar night. So radar is really useful for that, but also radar can be used through cloud cover, which is also really important because Antarctica is quite a cloudy region. So I'll be using these satellite data to principally map the velocities of the ice. So what this means is it maps how quickly the ice flows over time. Specifically, I'm going to be looking at how this velocity varies over seasonal timescales, so whether it differs between summer and winter rather than over annual timescales. This is purely because we already know quite clearly what's happening over kind of annual, decadal timescales, so year on year. The ice is speeding up because of climate change. But what we don't yet really know is how these glaciers are responding on a seasonal timescale to climate change, so they might start speeding up in the summer. Already we see this happening in mountain glaciers, so places like the Alps and in high mountain Asia, and also Greenland, where we see melt in the summer causing a speed up in the summer, and then snowfall in the winter causing the glaciers to slow down again. But we haven't yet observed this in Antarctica. This is because Antarctica, it's a lot colder down there, and the ice tends to be frozen to the bed, so it doesn't vary on as short a timescales as it does elsewhere. But with climate change, this might start happening, so that's what I'm looking for. With climate change, there's more and more surface meltwater in Antarctica, which might start causing these summer speed-ups and perhaps winter slowdowns with increased snowfall due to climate change as well. So that's what I'm currently focusing on at the moment. I look specifically at George VI ice shelf, which is located on the western side of the Antarctic peninsula. But there's also scope for this research to look beyond this specific ice shelf to the whole of Antarctica. It'll be really interesting to see if this is happening everywhere or just in the Antarctic peninsula, which is the warmest region of Antarctica. And then also it'll be really interesting as well when my research takes me on to trying to explain why these variations are occurring. So perhaps looking at different ocean forcing mechanisms, but also mapping surface meltwater as this increases due to climate change. Overall, I hope this research will contribute to furthering our understanding of how Antarctica will respond to climate change in the future. Thanks for listening.